Okay, so welcome to Unit 4. Unit 4 is called stoichiometry. And what we're going to do in this unit is we're going to start calculating quantities of the chemical reactions. So, like in Unit 1, we started with looking at the periodic table and the elements. And Unit 2, we took those elements, combined them to make compounds. Unit 3, we start to react them together, balancing equations, looking at the reaction types. So now that brings us to Unit 4. So now that we're comfortable and confident with elements, the compounds, and reacting them together, we're going to actually analyze, well, if I put this mass into this chemical reaction, what will happen to the product of the specific product that comes out of this reaction? How much of that substance will you have, and so forth, okay? So not even, we're not just going to analyze the mass of things, we're going to actually, if we had an actual camera that can look and count every single particle that's inside of that, I don't know, 5 grams of sodium chloride, we're going to actually count how many sodium chloride compounds, molecules that there are in the sample that we have. So it's a very lot of math in this unit, so we're going to start off today with scientific notation. So just because, again, if you are counting how many sodium chloride particles are in a small sample, you're looking at a lot of particles, okay? So we need to be able to count them and to be able to write a number efficiently so that we aren't making errors because we have to deal with such large or small numbers and so forth, okay? So scientific notation is a convenient way to write very, 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 very large numbers or very, very, very small numbers. So I'm going to teach you how to write big and small numbers. We're going to, in general, deal with big numbers in this unit. But again, like you might need it in a biology class or some other, physics class or so forth. So be able to do it both ways. All right. Okay, so what we have here in this table here is the standard form. So just in general, what you guys have been writing all your numbers as in standard form. So if you were a scientist and you had to tell someone across the world 120 and then 0, 0, 0, 0, 0, 0, 0, 0, 0. At some point, you might get tired. If you have to write that several times in your report, you might forget a zero. Okay, so that scientist that's receiving your report is going to look at that one value, say that you made a mistake in, and I don't know, create something and end up blowing it up, or something might happen because you didn't write the number out correctly. And again, it was annoying because you had to write out 10 zeros, right? So that's why you're going to learn a shorthand, convenient way of writing it. And here on the right side of the table is the scientific notation. So this value is equivalent to this value here on the left, okay? And here's a small, tiny, tiny, tiny number. And again, here's the equivalent form in scientific notation. So it's a lot easier to write out, and then you can send that to somebody, and then they'll know exactly what number you're dealing with, and then there shouldn't have been any mistakes with how many zeros you wrote out and so forth. Okay, so it's kind of like a lazy way to write the numbers because, yeah, you don't have to write all these zeros out. All right, so let's actually get to practicing here. All right, in general, you're going to have the form will look like this. You're going to have a number in front, and then it'll have a times, okay, and then 10 to some exponent. So that's what the form will always look like. So if we're looking at the number in front, the A here, the condition is that this number has to be between a number between 1 and 10, okay, but not including 10, so up to 10, okay? So, so 9.999 is okay, but you're not going to write 10 times 10 to the right, so you're going to write 1, 2, 7 times 10 to the, and then on top of it, this can't be lower than 1, so you start at 1, okay, or go higher up to 10, okay? And then the n here is the exponent, and so what you're noticing here, when you have a large number, it should be a positive number, and if it's a small, tiny number, will have a negative number, okay? So just kind of use that as a check later when you're going through these questions. Oh yeah, I have a big number, so I should have a positive exponent, okay? Or a small number, I should have a negative exponent. Okay, so let's go from standard form to scientific form now. So I'm just going to show you some examples that are already done here, and then we'll try some together. So step one, what you have to do when you have a number, like for example, this big number in here that you had looked at first, where is the decimal in this question, okay? Like for example, in the next one here, here's a decimal right there, so that one's easy to find. So where would the decimal be in this question? Well, we don't write it in, but it's right here on this end. So that's key, find the decimal first. Okay, so there it is in this question here. So now what you want to do is you want to move the decimal until you move it between the numbers, so you have a number between 1 and 10. So, so we're going along here, moving it, and say if I stopped it right here, I would have a number 6,500. Okay, that's not between 1 and 10. So I'm going to move it over again, and then I'm at 650, still not what I need. One more, I'm at 65, still not between 1 and 10. Move it one more, 6.5. Okay, so 6.5 is okay. You can have that number as your A value. If you were just having too much fun and making a whole bunch of arrows like this and went one more over, you would have 0.65. 0.65 is too small. It's not between 1 and 10. It's lower than 1. So that's what you're going to do. You're going to move it and till you get a number between 1 and 10. And so here it is, 6.5. Okay, and then you're going to write times 10. Times 10. All right, and this number 7, where did it come from? The exponent comes from how many moves you move the decimal. Okay, so this decimal point, you move it 1, 2, 3, 4, 5, 6, 7. Okay, so you moved it 7 spots to get the number between 1 and 10. So then you write 7 up here, and that is the scientific notation version of this standard number here. Okay, standard form. All right, so that's what you do when it's a really big number. When it's a small number, okay, so here again, identify, figure out where the decimal is. There it is. And you want to move it until it's between 1 and 10. So for example, if I stop right here, that's 0.9. 9's not between 1 and 10. If I move it over one more, 9.8. Yep, that's good, right? But if you're having too much fun and you went one more over, that's 98.7. Okay, so that's not between 1 and 10. So you want to stop it right here. Okay, so then you're going to write 9.87, and in general, what I usually do is I'll write kind of all of the digits that are not 0, I guess. Just you can stop there, 6.5. Here I write 9.87. So again, when in doubt, just add a few extra decimals. Okay, it's always good to carry a few. So 9 point, and again, if you are a physics student and you know how to do sig figs, just use your sig figs here. Okay. So yeah, 9.87 times 10 to, and then we move to 5 spots. So 5 will go here. But then remember, if you had a small, tiny number, right, you're going to have a negative exponent. If you had a really big number, you'll have a positive exponent. Okay, so those are the general rules. So let's actually practice them now down here. Okay, so I recommend that you use a pencil when you're practicing this, because you want to kind of move the decimal around and make some adjustments. And if you make a mistake, it can kind of get messy. So, okay, I just made the number really big, so it's a little easier for see what I'm doing here. So we're finding the decimal first. Okay, so there it is. And now we're going to move it so it's between 1 and 10. So we're going to go 1, 2, 3, 4. So see how from where the decimal was, I was just looping it, going between the numbers. Okay, so that's because again, if you're moving the decimal, you would move it here or here or here. So again, we're trying to move it until we get a number between 1 and 10. So we're going to stop it right there. So if we do that, that would become 2.5, which is a number between 1 and 10. Okay, so yeah, just kind of 1, 2, 3, loop it through like that. So from there, write the 2.5, then you're going to write the times 10 to the, and then the exponent is how many moves you made. So the decimal is moving along here, 1, 2, 3, 4. Okay, so there it is. So again, I just wanted to point out here. So your goal is to move between a number to a number between 1 and 10. So if you're just having too much fun here at 1, 2, 3, or maybe your hand cramped and you had to stop right there, that would be a number that's 25. Okay, and that's not a number between 1 and 10, so not that one. So again, this is where we stopped, right? That was the crack spot. Say like you were just having too much fun, you went all the way to here, then you would end up with 0.25. Again, that's not between 1 and 10 either, so you're not going to use that number. Okay, so just be careful as you go through to push the decimal along the right number of spaces. Okay, so again, you started here. So here's the first spot it can go. Nope, that's not good. 2, 3, 4. Okay, and that's the exponent. All right, so let's try the next one. Same thing, decimal's here. If you don't see it, it's there. All right, and then let's go along. 1, 2, 3, 4, 5. Okay, it's 1.0 times 10 to the 5. Okay, and then the next one here. There's a decimal, and again, let's move it. 1, 2, 3, 4, 5, 6. Okay, so I am moving the decimal, so it's a number between 1 and 10, and then I'm writing times 10 to the how many moves I made, and then if you're wondering like at what number do you drop off, like do you keep all the numbers? Yes. If there are a bunch of numbers, like for example, I don't know if you had a number like that, and then you had to, go through the steps, then you stop it right there, right? If you wanted to, you could just kind of carry a few digits at least, like, I don't know, 3 digits, okay? For the physics students, just like if you're taking it and you know how to do scientific significant figures or significant digits, then you just kind of adjust it according to what you have in your calculation values, okay? All right, so yeah, just carry a few digits, so otherwise, and that's good. So I don't want you to just round this up to 1, okay? That's not good either. So, all right, there we go. So we are done all the big numbers. Now let's practice with some small numbers. Okay, so locate the decimal place. There it is. And then now, because we have a small number, we're going to move this way to try to get it to a number between 1 and 10. Okay, so we got 1, 2, 3, 4. Okay, so right there. So that's going to give us 3.25. Okay, that's a number between 1 and 10. Okay, so that's 1, 2, 3, 4 spots. Okay, and then remember, it's a small number, so don't forget, small numbers are negative, large ones are positive. All right, here's the next one. 1, 2, 3, 4, 5. Okay, small number, negative exponent. Okay, one more. Or no, I think there's a few more here. Oh no, this is the last one. Okay, so here, 1, 2, 3 jumps. All right, and we'll just keep all the digits here, times 10, drop the rest of the zeros, and was it 1, 2, 3? 3 spots there. Okay, and so yeah, just kind of practice lots of those so that you get good at those. Okay, so that's what you're practicing today, essentially. So just taking a big number, move it to changing it to scientific notation, or taking a small number, changing it to scientific notation. I'm going to show you how to reverse it. Not necessarily something we're going to do a lot. We're going to go more into scientific notation and calculate with scientific notation. But if you wanted to figure out how to go to standard form, I'll just quickly show it here as well. Okay, so starting with scientific notation, the value in scientific notation, look for the decimal point. So in this case here, the decimal would have been right here. So what you're going to do there, if it's a positive exponent, you're going to move you're going to jump towards the right, okay? And so basically from here you go this way. So you're making the number bigger and bigger. If you have a negative exponent, that means it was a small number, so you're going to start at the decimal point and move it to the left. Okay, so to show that it's a small number. Okay, so let's try some examples here. Okay, so now we're moving to taking it back into standard form. Okay, so I'm just going to give you some more space here so you can see what I'm doing. So we're going to move the decimal a certain way in order to get it back to standard form. So for this one here, we're looking at it and we're noticing that it has a -4, so it was a small number. So we're not going to add zeros this way because that'll make it a big number. We're going to add zeros to the left of the number that we have here, okay? So if we have 2.7, I'm just going to write it separately from the rest of the scientific notation value. All right, so it's -4, so we're going to move it 4 spots. So we're putting the decimal back where it was, 4 spots. Okay, 1 spot, 2 spots, 3 spots, 4 spots. And then we stop it here, put the decimal. Okay, so now in these little, I don't know, rainbows, if you want to think of it, there was a 0 and a 0 and a 0. Okay, so we're going to put a 0 in for every little loop that you made here. Okay, so now if you double check here, the 2.7, the decimal is here, and now you're going to move it 1, 2, 3, 4 spots. Okay, so let's write that out. So write the decimal, and then 1, 2, 3 zeros, and then the 2, 7. Okay, so that decimal is no longer between 2 and 7. It's over here now, and people like to write the kind of the leading 0 here, 0.00027. Okay. All right, let's try the next one. Again, I'm going to just write it separate here. Okay, so it says -5, so we're going to move 5 spots. So again, it's a small number, so we need to move this way to the left. So 1, 2, 3, 4, 5. Okay, and then put your dot there. All right, so go put a 0 in for every little loop here. Okay, so it moved 1 spot here, 2 spots, 3 spots, 4 spots, 5. So we need 4 zeros, 1, 2, 3, 4, 2, 5. Okay, so again, same thing, you're not going to write that decimal, you moved it. Okay, so sometimes I have students writing it like this, but then they keep the decimal where it was and then where now it's supposed to be. Okay, so just little errors like that, I'll have to take off marks, so just be careful. Okay, so those two both had a negative exponent, so they were small numbers, but the next two have a positive exponent, so they're the big numbers. So what you're going to do here is, again, I'm just going to write it separately. Okay, 3.7 like that. And then the exponent 6 here is telling me to move the decimal 6 spots. So again, it's a big number, so you want to go and put the zeros on the right of it. Okay, so let's move this way. So that's 1 spot, 2, 3, 4, 5, 6, and we'll put our dot there. Okay, so that first little rainbow, okay, has the 7 in it. So then the next one's empty, so let's put a 0 in all the empty ones, okay? All right, so now if we count again, 1, 2, 3, 4, 5, 6. Okay, so we know we have 5 zeros. Okay, so, people find it trickier to go back to standard form, so if you're not sure if you did this question correctly, you can go back and go back and shift the decimal back this way and see if you actually get to this number here. Okay, so if it starts here, 1, 2, 3, 4, 5, 6. Yeah, so we know we have the right number of zeros. Okay, so try the next one here, 5.81. So again, I'm just writing it separate. from the form so I can move it along. Okay, so this one is 12 shifts. Okay, so you have 1, okay, between the 8 and 1, 2, the one after 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's our decimal. Okay, go put the zeros into all the empty loops. So 1, 2, the first 2 little jumps here, the 8 and 1 are in there. So from there, let's put a 0 in the rest of them. And one last loop. Okay, so now you're going to write it as 581. That looks like 10 zeros. Okay, 6, 8, 10. Yeah, 2, 4, 6, 8, 10. All right, so there is our number in standard form. So hopefully you see like that's a times 10 exponent there. So it's so much easier to write in scientific notation than to write it like that. Okay. Okay, so again, we're going to be working with values that are already in scientific notation. Sometimes we will need to convert it into scientific notation, but usually we'll be given a number that's in scientific notation. So like right here, what you see here is this is what your calculator will show you for a really special number that we're going to be using in this unit called Avogadro's number. So it's so if so if I'm actually writing that out in like scientific notation, it would look like this. So it would be 6.02 times 10 to the exponent 23. Okay, so this is a number that you're going to use a lot. So you have to, sometimes you need to write, you're going to be using a calculator with a lot of big numbers, okay? So I'm not going to expect you to do them in your head, but you will need to know how to write it properly. That's why we're practicing it right now, so you understand what this big number, like if you see it in scientific notation, you should understand what this number represents. Then from there, what I'm going to teach you below here is how to use your calculator so you can enter these values into your calculator and then you can read them off of your calculator as well. So I'm going to start with using just a typical scientific calculator. So I found one online that I was able to download to my computer. It's not the best. It looks really fancy, but it's quite glitchy. So anyway, if you wanted to download one of these two, this website, Casio, I don't know, I think I Googled Casio Scientific Calculator and they're allowing you to download it for free for the next 3 months, just with everyone moving to remote learning. So if you look here, so I just was calculating. Anyway, I don't know. It's almost too complex. Anyway, we're trying to enter in this scientific notation number here, 2.2 times 10 to the negative 11. So if you are on your scientific calculator, like for example, like the one you bought from school, you're just going to type in 2.2. So you're going to write the A value, the number that's in front. You're not going to put in times 10 to the, okay? There actually is a scientific notation button. So usually it's located here, or I think sometimes for some people's calculators it's around in this corner. Anyway, so for this one here, it's times 10 to the x. So you're just going to click on that, and it tells the calculator that you are entering a scientific notation number. So then from there I need negative 11. So the negative sign is here, negative 11. Okay, so those are the steps that you need to use in order to enter it into this calculator. So I'm going to write that down here. And then I want you to do the same thing. And so like if you hit equals, it'll actually accept the scientific notation value and write it that way. So anyway, we're just going to write out the steps that you need to take in order to enter it into your calculator so you can use this as a reference later. So I wrote down here the steps that I used to enter it into that scientific calculator that I just showed you here. Okay, so I entered 2.2, Okay, and then I hit the button times 10 to the x, and then I put in negative 11, and then hit equals, and then the calculator accepted it, and it's showing right there. Okay. So I just grabbed some pictures, screenshots of an iPhone, Android, and just some other calculators. So if you're trying to find this mode here on your iPhone, you just have to turn off your rotation or lock, okay, and then turn your phone sideways, and then you should see a scientific calculator like this. So without it, you would just see kind of this area here, but when you rotate it, you'll see all of this here. So if you're using your iPhone in order to add scientific values, the iPhone has the button where it says EE. So just try to take a look for that. Okay, so if you look here, that's the button that you need. So for example, if we're putting in 2.2, so you put 2.2, and then you would hit your EE button instead, okay, and then put in negative 11 and then hit equals, and then you'll enter the value in there. So I believe when you put it in, I'll show you what it looks like. Okay, so when you put it in, and just another reminder here, make sure that you don't put the subtraction sign in for the negative. Make sure you're using this button here for your negative sign, okay? All right, so when you put this in, your iPhone calculator can hold quite a few digits compared to a regular scientific calculator that you have. So once you hit equals, you'll see the number come out like with the bunch of zeros like this all the way to, okay. So that's normal. Okay, so I rewrote that. So that's what you'll see on your graphing calculator, your iPhone calculator, sorry. If you just have a typical scientific calculator, it can hold about 9 digits, so you would still see the value in scientific notation. But if it's your iPhone, this is what you'll see, okay? But the main thing is make sure that, yeah, you have 10 zeros and then 2, 2. So then you know you've actually entered this scientific notation value if you're using your phone. But again, I recommend that you have a scientific calculator on you. If you don't, okay, no worries, just use your phone then, but you're going to find it a lot easier to calculate with if you have a scientific calculator, just because the iPhone kind of forces you to put things in backwards sometimes, and yeah, it's hard to carry through lots of different calculations with a phone. So all right, anyway, so that's what you would see with the an iPhone calculator if you're trying to enter those values. So go ahead and try the other one as well. But then just jot down these notes saying this is how I would do it if it's the iPhone, but if it's your scientific calculator, like the one I had here, I used this button right here. That's the exponent button, okay? All right, but if you have an Android, I kind of took some screenshots and this is what I found. I think this is what you guys see. So I don't see a scientific notation button here. So another way that you can go about doing this is just that if you can hit the scientific notation button, it just kind of saves like the steps of going through and adding like times 10 to that and so forth. So if you guys like, maybe if you just look up and see maybe tutorials on how you would do it on an Android, but if not, when it comes down to it, if you just go in and just type in 2.2 and then hit the multiplication symbol, okay, and then put in 10, and then you need to use your exponent button, which looks like it's this one here. Okay, so it looks like it's a little bit grainy, so I think that's what it is, y to the x. So you want to look for something that looks like that. Okay, so if you do that, it's saying, okay, take 2.2 times 10 and then hit this exponent button and then type in the negative. And I think, yeah, here's the negative button, negative positive button here. So negative 11, right? Yeah, 11, there. And then hit equals. So that's how you would enter it on an Android phone, okay? All right, but if you do have a scientific calculator, you might have this times 10 to the X button, but here I took another picture. A lot of calculators have this EXP. Okay, so EXP button, so you might have that on your calculator depending on what you have. I've seen some calculators have an EE button. Okay, so you might need that one. Trying to think what other ones. You'll have variations of this times 10 to the button. Okay. Okay, so yeah, you can have a capital EXP or it can be a capital E and little X and P after. I just found a picture of the one that a lot of you guys have from our school Cash Online. And yeah, like, so right there, if you can see, is the scientific notation button. Okay, so circle it here. Okay, there it is. And then here is the negative button. Okay, so add that. So again, when it comes down to it, if you are trying to enter the scientific notation value into your calculator, you want to go to point 2 and then you hit your button here, whatever the button is for your scientific notation. So say in this case here, it's capital E, little p, X, little p, and then you write negative, so you hit the negative button, and then 11, and then hit equals, and then that's how you enter it in. But when it comes down to it, you could just, if you can't remember, you just type in what you see. So you go 2.2, and then you see multiplication, right? So you hit the multiplication button, which is here, okay? And then you just go 10, you type in the 10, and then you know it's an exponent. So the exponent button, for example, on here is right here, okay? So you can hit the exponent button and then the negative 11. Oops. Okay, so it cuts down a few steps of having to, punch through all these things in a calculator. So, but if you're like, I don't know, if the XP really bugs you and you don't want to use it, then you can do that. I think some calculators, if you're trying to find this button, you'll find that sometimes it's X to the Y. Okay, some of them will just have this roof button. Okay, because that's how you program an exponent into a calculator or computer. So yeah, so if you're just trying to look for those, like if we look back here on these ones here, it was, where is it? Oh, and then sometimes it's like above it. Okay, so you have to look above. So you have to hit shift and then get to the button that you need. Okay, and then here, if it was an iPhone, if you wanted to do that, you just go 2.2 times 10. And then with the iPhones, like, you can't see what you're typing in. It kind of disappears as you hit the next key and so forth. So that's why I recommend like a graphing calculator that can carry and kind of show you what you're doing. So you have 2.2 times 10, and then you'll hit, it'll be this one here, okay? And then negative 11 equals. Okay, so go through and try the next one here, 3.25 times 10 to the 45. And then also what I want you to do is kind of jot down what it looks like on your calculator, okay? Okay, so this picture here, when I entered 6.02 times 10 to the 23, the calculator I happened to grab, this is how it would show me that, oh, you just entered a scientific notation value. Okay, so it shows the E is the times 10 to the exponent 23. If we entered it on this calculator here, negative 11. Okay, when I hit enter, so that's what it looks like. It's a little tiny 10 and a big exponent and so forth, okay? Okay, so this one here is quite big, so it won't turn to a decimal like it did down here with so it will leave it as a scientific notation format. So if you look at it, it would look like this on your calculator. So 3.25, and then it has a little e, 45, like that. Okay, so the main thing here is when your calculator is showing the answer like this, you cannot write it like that onto your test or your assessment. So I need you to make sure you switch it back, convert it back, translate it back to this form here. Okay, so that e is the times 10. The number that comes after the e is the exponent. Okay, so anyway, we're going to, now that we've kind of looked into how to enter it into your calculator, we're going to actually do some calculations now. Okay, so let's go down to the questions here. Okay, so and whenever you have like complex calculations to do, you always want to use brackets. So just make sure to throw those in wherever you can. All right, so let's start with the first one here. I want you to take your calculator, your scientific calculator, or if you don't have one, use your phone, and multiply these two together. So again, when you're going in and entering like a scientific notation value, it takes a few steps and so forth. So put it in brackets and then multiply, put the next one in brackets, and then hit equals. Just because a lot of things can get messed up. Your calculator sometimes doesn't know that exponent belongs here, and then that you're supposed to not multiply this yet, and so forth. So anyway, just careful when you're entering it. So go through, add those in, and calculate them out. And I'm going to write up the answer. Make sure you have the same answer. Okay, so I brought out this desktop scientific calculator out again. All right, so I'm taking 3.5, okay, and making it times 10 to the negative 4. So what I'm going to do here with this first one is I usually hit equals, okay, or enter or answer, whatever it is on your calculator. So it kind of puts it into the calculator ready to go. So then I'm going to hit multiply. So it's going to take that one I've just put in, and then I'm going to go bracket 4.8, okay, scientific notation value of negative 7, okay. All right, so I'm taking 3.5 times 10 to the negative 4 and multiplying by 4.8 times 10 to the negative 7, hit equals, and then this is where you have to be careful. So I'm using a scientific calculator that is not writing it perfectly. It's writing so for example here, if I write, okay, so we're looking at the calculator, we calculated the numbers in, and then this is the format that it gave me. It was 1.68, a little tiny times 10 to the, and then the negative of the exponents right above that little 10, and then the 10's kind of halfway through the air. So if you literally write it exactly the way you see it and on paper when you hand in your assessment like that, I will take off some marks. I want to see that you know how to translate it from your calculator back onto your sheet here. Okay, so you need to go 1.68, and then the times 10 is big, and then that negative and so forth that comes after is negative, and it's like a little 10 like that up in the air. Okay, so don't make sure, like, I know your calculator is writing it a certain way because it has to, but don't be writing it the way your calculator is. Make sure you're converting it back to look like scientific notation on paper. Okay, so again, your scientific calculator on your iPhone, you have to have a pretty large or pretty small number, otherwise it'll just write all the decimals out. So you're going to have to actually go through and put it back in scientific notation, because I don't want an answer where there's like 15 zeros and so forth, and just because your calculator can handle it. Okay, so I want an answer in scientific notation. So so if I give you one here where this is what it might look like if it was in scientific notation on your iPhone, it would give you that little e and write it like that. Okay, so if you write your answer like that and then hand it in, I'll take off marks. Okay, I understand what that means, but that's not how we write scientific notation. So you have to convert it out of the calculator language, okay, back into scientific notation. So that e, so 1.68 is still the same. That e becomes times 10, okay, so it's like abbreviation for times 10. And this number that follows the e is the exponent. So you have to write it small up in the air on the right along with the negative. Okay, go ahead and try the next one. Okay, so again, make sure that you are actually getting the exact answer that I'm getting. So if you are off by 1 for the exponent, that's a big deal, okay? That's a huge difference in the value, and again, could lead to errors if you were actually out there working in the real world, like for a company and so forth, okay? All right, so let's go through, enter this one in. So again, if you want me to just delete all of the stuff out of here so it's not distraction. Okay, so again, just to be safe, on the safe side, let's put brackets in, 1.5. Okay, and then times 10 to the negative 8 brackets. So here I'm just going to calculate them all together instead of hitting equals and entering it into the calculator. And then multiply by bracket 5. Oh, actually, sorry, let's go back. It's divide bracket 5 times 10 to the 12 bracket. Okay. All right, so just double check that you did everything right. Yeah, you put negative 8 in, positive 12. Now we're going to hit equals. Okay, and again, the calculator is giving me its form of the answer. So if I write that in here, oops. Okay, so the calculator gave kind of a form like that. All right, so just it looks like it's about right, but it's not quite. I know that times 10 is not supposed to be a little subscript, okay? So just adjust it and then, yeah, show me your final answer. Okay, so make sure, yeah, take that little times 10, write it bigger, and then make the 21, negative 21, an exponent. All right, here's the next one to try. So again, you should be getting the exact same number regardless of what calculator you're using, okay? If you're not, you need to kind of double check what you're entering and so forth, okay? And if you're still having issues, just email me. I can try to show you online. All right, so let's try another one here. I'm going to delete these out. Okay, so bracket 3.6 times 10 to the 6 bracket. Okay, when things are right beside each other like that, that means multiply. All right, 2.4. Okay, there we go. And then I'm gonna hit equal. Okay, it's always good to, like when you're going across the top like that, to clean up the top. Okay, so hit equals. Okay, I get a big scientific notation value. So then I'm going to go divide. So it's taking my previous answer, divide bracket 2.7 times 10 to the 3 and hit equals. Okay, so I got 3.2 times 10 to the 11. So I'm just gonna like when I was over here and I was entering like writing down what it looks like on the calculator, like I was just showing you that, just show you that you shouldn't write it like that. But when you see it on your calculator, once you get comfortable, make sure you just write it right into scientific notation. Okay. And what was it, 11? 11. Okay, and you're done. So again, today's lesson was getting introduced to scientific notation. You may have seen it already in one of your classes. And so the whole point of learning this is that you want to be able to take some really large or small numbers and write in a kind of compact, convenient form that you can, it's easy to transfer from one document to another, or communicate it to someone through email and so forth, okay? So we started off with changing it from standard to scientific notation, okay, trying big numbers and tiny numbers. And then we reversed it. We were taking it back out of scientific notation and putting it in standard form. And then I was telling you about this number. You're going to use it a lot, 6.02 times 10 to the 23. It's Avogadro's number. So it's a number that you need to calculate with to find some other values. And so you need to be able to enter that into your calculator, okay? But then at the same time, you have to understand what the actual number looks like in standard form. So hopefully you see that it's a big positive number. So you're going to have, something that looks like this, okay? But Like here, this was 10 to the 11th. So now imagine when it's times 10 to the 23, how many more zeros you'll have, okay? So, um, so yeah, so just make sure you understand how big that is. Understand that it's just a convenient way of writing it. And then you should also be able to enter it into your calculator. So that's what we practiced here. But again, I know we're at home right now, and I don't know, you guys don't know I don't know which calculator you're using. So I tried to think of all the buttons here. So it's either EE or times 10 to the X, or it's the EXP buttons. Okay, that will work. But again, when in doubt, you could just go to 2.2 like times 10 to the, hit the exponent button here, then write negative 11 equals, and that's another way to get the value in there. Okay, so just just maybe there's one lying around in your house, so just try to find a scientific calculator. It's going to be easier than using your device. Okay. But if you wanted to download like something like this, I found that it took me a while just to clear the screen. But anyway, you can download one like this. They're offering it for free for the next few months with remote learning. So you can do that as well. Here's one that if you have a school calculator, okay, I showed you where all the buttons are. And yeah, and then we finished off with some calculations, okay? Just because we will be doing this a lot where we're calculating several numbers. Some of them will be scientific, some of them won't be, and you need to be doing it correctly because you'll do a lot of work and then you'll end up being off because maybe your exponent was off or you wrote something wrong. So just make sure these are good, okay? So please practice these, check your work, make sure you're getting them right, and then try the checkpoint.